Hey class, today we're going to look at inscribed angles in this video. Now in the last video that you looked at, if you're watching these in order, we talked about inscribed polygons. Now remember that's when a polygon has every vertex on the surface or the outside of the circle. Okay, this section is talking about inscribed angles. So this is an angle that has a vertex on the circle and the sides are chords of the circle. Okay, now the intercepted arc is the arc that has the endpoints that are on the sides of the angle and are inside the angle. Okay, so basically what we've got is we've got a couple cases here that I want to have you guys looking at. So here's the first case. We've got a center P that's on the side of this angle. So here's your vertex. Here are those two chords. That's your inscribed angle. This then would be the arc. Okay, that's the intercepted arc. The second case is when the center is on the inside of the angle. So here's again your vertex, here are your chords, that would be your angle, or sorry, your arc. And then the last one, you've got your center here, it's on the outside or the exterior. So there's your vertex, here's your sides or your chords, and that's your arc. Okay, now what happens is based on these, we've got a theorem that comes into play, and it's used quite a bit. So it says, if an angle is inscribed in a circle, then the measure of the angle is 1/2 the measure of its intercepted arc. Okay, so basically this angle here, this angle 1, is going to be half the measure of that actual arc because that's an inscribed angle. Okay, so the interior angle, or that angle there, is 1/2 the measure of that arc, okay, of that inscribed angle. Alright, so what we've got is a question here that we're going to be looking to answer. So it says, find the measure of angle P. Then we want to find the measure of angle O, and then we want to find the measure of arc PO. So we've got a couple different things, but here's what we're looking at. So we want to find the measure of angle P. Now angle P is this angle here. Okay, now it's an inscribed angle, and it's basically holding this arc, and that arc is 70 degrees. So what we saw is the angle is half the arc. So angle P is equal to 1/2 the arc there, which is 70, which means the angle P is 35 degrees. And there you go. Okay, so that's your angle. Now the second one says angle O. Okay, so angle O is this angle right there. Well, it intersects that arc. So angle O is going to be 1/2 of, again, 70 degrees, which is 35 degrees. Now we're going to come back to that in a few minutes. Because there's something interesting that happens. But that's how you're going to find those. So figure out which angle and which arc match up, and then the inscribed angle is half of that arc. Now the second one is we want to find the measure of arc PO. So here's PO here, and it's created by this angle, and that angle is 56 degrees. So the arc is always twice the angle, and the angle in this case is 56. So the arc equals twice the angle of 56, we multiply by 2, we get 112 degrees. So that arc has a measure of 112 degrees, and there you go. Alright, so that's how these questions work, and how that theorem actually sets up. Okay, so your inscribed angle is always 1/2 the measure of the arc. Alright, so what we saw up here above, the P and the O are the same. And that's actually the focus of another theorem. And it says, if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So you can see here from this picture, we've got this angle DCA and this angle ABD. They both intersect the same arc there, which means that those two angles are then congruent. And that's what those marks mean. So that's one of these theorems that, again, comes into play quite often. All right, so here's an example. Find the value of x, and then find the angle measure for each angle and the arc measure. All right, so we see these angles are that one created there, and this one created here. Now, because they both intercept this exact same arc, they are equal values. So I've got a 3x minus 5 is going to be equal to 2x plus 15. And so we're going to solve this. Okay, those two are congruent, so we set them equal. So subtract 2x, add 5, do the same thing on both sides. Those cancel. You've got x equals 20, and there's the value of x. Then it says find the angle measure. Well, we can find the angle measure by taking our x and substituting it in. So I've got 2 times 20 plus 15. So 2 times 20 is 40, plus 15 is 55. So what that's telling you is that each of those angles is 55 degrees. Okay, then we can expand that even further because it asked you for the arc measure. Well, like we've said, the arc here, or the angle here, is half of that arc. So if I take my angle and I multiply it by 2, so that's 55 times 2, I get 110 degrees, and there's that. So we know what x is. This is our angle. This is our arc. And we have now answered everything that this question asks us. All right, let's take a look at this next one. So we've got this angle, or this essentially angle here. Now what you've got going this diagonal, that's a bad color to use, this one here, but this right here is our diameter. Okay? And we know that a diameter crosses through the center, which I covered up with this mark, but there it is. Okay, it goes through that center, which means that this here is a semicircle, or 180 degrees. So what that tells you is that the angle that is inscribed is half of 180, or 90 degrees. So this angle right there is a 90-degree angle. All right, so we're going to take some of that from the picture we have. Now, what can we do to solve this? Well, we know that all the angles of a triangle have to add up to 180. So if I take 4x plus 2 plus the 9x minus 3 plus the 90 degrees, which we already know, I add those together, they have to add up to 180. Three angles of a triangle always add up to 180. And now we solve. So combining like terms, that gives me a 13x. I've got 2 minus 3 is negative 1. Plus 90 would be plus 89 equals 180. And start solving. So I subtract 89 from both sides. That gives me 13x equals 91. And then I take 91, I divide by 13. That gives me an x value of 7. And there you go. And now what they could do is they could, as always, ask you to solve the other values. So if I wanted to actually find that angle, I would just substitute the 7 back in. And so 9 times 7 is 63, plus 3 gives me 66 degrees here. And because these things have to add up to 90, that means that this one, again, I could substitute in or solve it out, using any other method. But that one's going to give me 2830. And there you go. Oh, I got this backwards. Sorry, this one's 60. All right, there you go. Okay, hopefully that makes some sense. So what that does is it leads to a couple more theorems. Here's our final 2 theorems for this section. It says if the inscribed angle intersects the diameter, the angle is a right angle. And we just saw that in the last case. Because it creates a semicircle. Semicircle is 180 degrees. Half of 180 is 90, which is a right angle. Okay, the other one says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, so what we've got now is this case here. So a quadrilateral, remember 4-sided figure, is inscribed in a circle. Opposite angles are supplementary. So opposite means they're across from each other. Now there's 2 ways you can work through this. Because these two, I hate to use a congruency marker, because those 2 are opposites, they're going to be supplementary. Okay, these 2 are opposites, they're going to be supplementary. So what I could do is I could take each of those individually, add them together, and set it equal to 180, because that's supplementary, and solve them. Or, because all 4 of these have a sum of 360, because it's a quadrilateral, I could add them all together and set it equal to 360. So it's kind of up to you which way you choose. I'm going to just take 2 of them, since that's what this theorem says, because they're opposites, and make them supplementary. So I've got 7x plus 10 equals, so plus, because it's supplementary, meaning I add them together, equals 180, and we solve. So 7x, 10x is 17x, plus 10 equals 180. Subtract 10. That leaves you with 17x equals 170. Divide by 17. And you now know that x is 10. So we found x, and that's the case for all of these. And so now we can take them and substitute them back in and figure out the actual angle measures. Okay, so if I take 10 and substitute it there, that angle is 100 degrees, which means because it's supplementary, this one should be 80 degrees, which it is. Yeah, I take my 10 and I substitute it right back in there. 12 times 10 is 120. Minus 10 is 110, which means the one opposite it should be 70. And now I've got all of my 4 angles, and you're done. So that's how inscribed angles work. If you have any questions, definitely contact me, let me know, and hopefully you can get through these and we got all your questions answered. All right, good luck. Talk to you soon.